We are demonstrating a theorem called the squeeze theorem, which is used to show that the derivative of sine x is cosine x. And here is the squeeze theorem right here. All right, it says that we have the following limit. The limit as theta goes to 0 of sine theta over theta is equal to 1. Okay, now the proof of this theorem is geometrical, and it's based on this diagram. This is a diagram of a circle centered at 0 with radius 1. And we have drawn three geometrical figures, this blue triangle, a red sector, and a large purple triangle. All three of these geometrical objects share an angle theta here at 0, 0. Okay, now this point over here is cosine theta, sine theta. All points on the unit circle can be represented as cosine theta, sine theta, where theta is the angle underneath the radius, or the angle that the radius makes with the x-axis. All right, what we're going to demonstrate, what we're going to use actually in order to show, demonstrate this limit, is we're going to first calculate the area of the blue triangle, the red sector, and the purple triangle. And obviously the blue triangle is the smallest of the three, and red is in the middle, and purple is the biggest. Okay, so let's take out these three geometrical objects and calculate the area of each one. We want to calculate the area of the blue triangle, the red sector, and this large pink triangle. Okay, notice that the base of the blue triangle is cosine theta, and the height is sine theta because of this point here. And the base of the red sector is 1, the same as the radius of the circle. And the base of the pink triangle is that same radius 1. All right, so let's pull out each geometric object and look at it outside of that diagram. And we'll calculate the area of each geometrical object. Okay, so I arranged them in order from smallest to largest. All right, now let's do a little bit of labeling. Okay, so we said the base of this triangle is cosine theta. Here we have an angle of theta, and the height is sine theta. All right, we have the same angle theta here with a side 1 for this sector. And here we have the same base 1. Okay, angle theta. And if you recall, tangent theta is equal to opposite over adjacent. All right, which would make this side, since the adjacent is 1, it would make this the height of this triangle equal to tangent theta. Okay, now that we did all our labeling, we can calculate some areas. Remember, the formula for the area of a triangle is 1/2 base times height. So for the blue, we have 1/2 the base cosine and the height sine theta. And then let's do this purple triangle. That would be 1/2 1 for the base and tangent theta for the height. And now for the red sector, if you remember, the area of a sector is 1/2 theta radius squared. So in this case, it would be 1/2 theta times 1 squared, which is 1. And then since we arrange these in order, we see we have these less than or equal to symbols in between. This quantity is less than or equal to this quantity, which is less than or equal to this quantity. Now we're going to do a little bit of manipulating of this double inequality. First, we can multiply everything by 2, which cancels these 2's. All right, I'm going to write tangent theta as cosine theta, sine theta over cosine theta. And now divide everything by sine theta. So on the left we have cosine theta. And here we have theta divided by sine theta. And here we have 1 over cosine theta. And now we're going to take the reciprocal of each quantity. And remember, when you have an inequality and you take reciprocal of both sides, the direction of the inequality changes. So we're going to change the directions of both inequalities and flip or take the reciprocal of cosine theta here. So we have 1 over cosine theta. In the middle we have sine theta over theta. And here we have cosine theta. Now remember, we want to show that sine theta over theta goes to 1 as theta goes to 0. So here we have it in the middle. And now we're ready. Now we want to take the limit as theta goes to 0. Well, remember, cosine of 0 is 1. So this quantity is going to 1 over 1. So this goes to 1 as theta goes to 0. And for the same reason, cosine of 0 is 1. This quantity also goes to 1 as theta goes to 0. And sine theta over theta is squeezed in between 1 and 1. This says that sine theta over theta goes to a quantity which is less than or equal to 1 and which is greater than or equal to 1. So we conclude it must actually go to 1. So that's the squeeze theorem. And what we've shown is that the limit as theta goes to 0 of sine theta over theta is equal to 1.